Section 4.1 is square roots and cube roots. First thing I want you to look at is how square roots are related to the area of a square. So here I have the area of the square is 169 centimeters squared, and we want to find a side length. I know that in a square, all the side lengths are the same. So if I was to find the area, I would take S, which is the bottom, times S, and when I multiply these two things together, I'm going to get S squared. But I want to figure out what the side length is, so what is S? In order to do that, I need to get rid of the squared. In order to get rid of the squared, I have to take the square root. So roots are opposite of exponents. They cancel each other out. So how do I do that? Well, I would take the square root of the area, which is 169, which is equal to, and on your calculator, you should know most of these square roots up to, I don't know, 14 or 15 times 15. This one happens to be 13. So the side length is equal to 13. Similarly, cube roots are related to volume of a cube. So if I have the cube here, I know that my volume is going to be equal to, volume is a side times a side times a side. In a cube, all sides are the same. Length, width, and height are all the same. So if I have this, this is going to be equal to S cubed. 1, 2, 3, S cubed. In order to find S, again, I have to do the opposite of cubing, which I know is going to be a root, but this time the root is going to be the cubed root, because the cubed root will cancel with the cubed. So for my S, for my side length, I'm going to have to take the cubed root of 343, which is my volume. On your calculator, most calculators have a little cubed root button. They have a root button up here, and they have a cubed root button with a little 3 above the root sign. So I have 343, and I take the cubed root, I get 7. So my side length is equal to 7. Repeated multiplication, you should know how to write repeated multiplication as an exponent. So here I have 7 times 7 times 7. All the numbers have to be the same. Then you can write it as 7 to the power of 1, 2, 3. And we saw above that 7 to the power of, and here's the power of button, or here's the cubed button. I can use either one. I can say 7 cubed, or I can say 7 to the power of, notice the little symbol it shows, 3. Either one is 343. This one, I have 3 to the power of 1, 2, 3, 4. And again, you can use your calculator, 3. I don't have a to the power of 4 button, so I just use this button, x to the power of y, or it'll look at like y to the power of x. Notice again that little symbol, to the power of 4 is 81. So repeated multiplication as exponents. What about exponents as repeated multiplication? Well, 5 cubed is going to be 5 times 5, so I have 1, 2, 3. And what is 5 to the power of 3? Again, we can do 5 cubed is 125. What about 6? So 6 times 6, so I have 1, 2, 3, 4. And 6 to the power of 4, 6 to the power of 4 is 1296. What about a factor tree? How does a factor tree work? Well, what it does is it breaks the number down into its prime factors. So the first thing I want to do is I want to find two numbers, any two numbers that multiply to 36. I know that 6 times 6 do, but if you were doing this a little bit differently, you could also say that 36 breaks into 12 times 3. Next thing I have to do is I have to break down each number into its factors again until I get to prime numbers, because 6 is not a prime number. 2 times 3 equals 6. This multiplication sign I have to copy down, and then 6 breaks into 2 times 3. So the prime factors of 36 would be 2, 2, 3, and 3. Notice also that I have two sets of the same factors. That means that this is a perfect square because I have two sets of the same factor. Over here, notice that 3 is already a prime number, so that one I'm just going to copy down, and the multiplication sign as well. 12, however, breaks into either 4 times 3 or 6 times 2. Doesn't matter which one you do, we'll do 4 times 3. Notice that 4 is not a prime factor, but the two 3's are, so those two 3's I can copy down, and the times as well. That times as well. What does 4 break into? 2 times 2. Notice I get the same prime factors, 2, 2, 3, 3, 2, 2, 3, 3, just in a different way. Using your calculator. We've already seen how to do this, but I'll go over 4 more examples just quickly here. 13 squared. 13 squared is 169. You should know that one in your head. 14 cubed, you wouldn't have to know in your head. So 2,744. What about the cubed root of 3,375? Again, you can use your cubed root button. Is 15. And the square root of 529, your square root button on your calculator, it looks something like that. Press it, and you get 23. So that concludes the lesson. Just know that square roots are related to area of a square, cube roots, volume of a cube. Know how to do repeated multiplication, exponents, factor trees, and know how to use your calculator.